In this tutorial, we will see how we can use Google Earth Engine machine learning algorithm to classify burned areas in Sentinel-2 image. We will be using random forest classifier and identify the burned areas like this, and then filter these burned areas. Finally, convert it to a shapefile and download to our local computer and smooth using QGIS. Let's see how to do that. First, open your Google Earth Engine code editor, then zoom to your area of interest. Today we will be using Sentinel-2 imagery in Madagascar because we can find a lot of burned areas there. First, let's turn on satellite imagery. And if you look closely, you will see a lot of burned areas are there. Using random forest classifier, we will classify these burned areas. First of all, let's add a rectangle. Click on this draw a rectangle button and then create a rectangle. This will be act as our ROI. Before making the training data, we need to filter and load the Sentinel-2 imagery for this region. Now let's exit the drawing mode. To classify the image using random forest, we will be using this code. I'll share the link with you so that you can easily follow along. You just need to copy this code and paste it to the code editor. Before going to the other analysis, we will be first load Sentinel-2 image. For that, we will need this part of the code. Let's comment out the other parts of the code. To comment it out, you should use Ctrl and /. In the variable ROI, we will pass this geometry. Let's copy it and paste. Now if we run this code, it will filter and load the Sentinel image of our ROI. We used Sentinel-2 surface reflectance harmonized image collection and then filtered the boundary with our ROI, filtered the date. You can change this date as you want, and then filter the image collection up to the cloud coverage 20%, and then take the median composite of all those images in the image collection, and finally clip with our ROI. This is the visualization parameters we used. This is band 4, band 3 and band 2 for RGB. Next, we added the image as a layer to our map. Let's run this. If we turn off the geometry, we can see that Sentinel image is loaded. You can go to layers and this settings button and then click on custom, stretch up to 3 sigma to make the image brighter. Click apply button. Now we are ready for making the training data. To make training data, we will be using polygon shape. So click this draw a shape tool and then create a new layer. Click on this edit layer properties button and then let's rename it as burned. We will make it as feature collection, and we also need to add a property. Let's make it class, and for burned areas we will be using class 1, and for non-burned we will use class 0. For burned areas, let's select the red color, click OK. Let's turn off the first geometry. Now we can make some polygons for burned areas. Let's zoom in and make some polygons there. You should make the representative polygons from almost all sides of your imagery so that it will better detect or better classify the whole image. Let's move to the left side of our image and make some training data. The more accurate your training data will be, the more accurately the classifier can classify your final image. Now let's do some annotations or training data in the top part. It's better to cover the whole image because the pattern of this burned area or other objects may be different in different sides of your image. Now let's exit this polygon drawing mode. So we have some training data for burned areas. Now let's make some training data for other areas, that is non-burned. Let's go to this geometry imports and new layer, edit layer properties, make it non-burned, import as physical action properties. This property should be same as previous one so that we can merge those feature collections together, and value should be 0 because we are using this as background. For background, let's select and color yellow. Okay. For background, we don't have to be that much precise because everything other than the burned areas are non-burned. So we can make bigger polygons, but make sure that your polygons doesn't contain any burned areas. Let's make another one in this part. Now we have the annotation for burned and non-burned. Let's click this exit mode. Now let's move to the code and uncomment the codes. Here for the background, we need to pass our background feature collection. The name of background is non-burned. Let's copy this and pass here as non-burned. And for the burned, we already have burned variable, so we can remove this or make it a comment. Then the map will be centered to the ROI. Here we are merging two feature collection, burned and non-burned, since we have different class value for those, so it can easily merge and identify based on the class value. Background has class 0 and burned has class 1. And for the bands, we used band 2, 3, 4, band 8. These are RGB bands. Band 8 is near infrared, and band 11 and 12 are shortwave infrared 1 and 2. And here we have to define the class property, since we made this class property, we have to make a string of same, that is class. We define a classifier, and within this classifier variable we use the random forest classifier of Earth Engine, which is called smile random forest. Number of trees we used 100, so 100 decision trees will be run by this classifier. For seed value we used 42. You can use any value as a seed. If you use this seed value, you can get the similar result every time. Otherwise, if the classifier uses a random seed, there will be somewhat different result every time. Next, we use the training data. We create a variable named training, and within this training, from Sentinel-2 imagery our selected bands. Using this sample regions function, it will get the values for burned areas pixel value and non-burned areas pixel value, and those values will be used for training. Here we passed our annotations as collection and class property, that is class for properties. And since Sentinel-2 imagery is 10-meter resolution, for most of the bands we use scale 10. For tile scale we use 16. Usually this value, default value is 1. If you run out of memory, you can increase this value. Otherwise you also can remove this. And with this code we trained our classifier. For that the code is classifier.train, and for the features we need to pass the training data and class property and input properties. Input properties will be use our selected bands. This, if we run the code up to this point, then our classifier is trained. Now we need to classify the whole image using our trained classifier. We make a variable called classified, and in this variable we used our loaded Sentinel-2 image and select the bands, the same bands that we used for training. We have to use the same bands, and then classify the image using our classifier. The name of the classifier is trained classifier. After classifying the image, here we add a visualization parameter, green for non-burned and red for burned. This one is for the first class 0 and this one is for second class 1. And then we add our classified image to the map. Here we use the parameter minimum value 0 and maximum value 1 because we have two values there. And for color palette we pass the palette we made and name it random forest classified image. Let's comment out rest of the code and run the code up to this point. The image is being classified and done. We turn off our geometries training data. Let's change the Sentinel-2 image visualization to 3 sigma stretch to make it brighter. We can also import this if we need. Now if we increase the transparency or reduce the opacity of the top layer, we can see the bottom layer. Let's change this to 3 sigma and apply. Now we have brighter and clear image. Let's close this and increase the opacity. You can see our burned areas are detected by the classifier almost accurately. If you are not happy with the result, you need to increase your training data. But for this example, I think it's quite good. Now let's move to the next part of our code. Let's uncomment first. Then we mask out all pixels that are not burned class. We make a variable named burned mask, and for burned mask we filter the classified image for the value of 1, which is only burned, and then apply the mask to the classified image and create the burned area image which only has the burned mask. For that we need to run classified.update mask. In this function we need to pass our selected filter, and for the visualization we need to use only one value. Here there is a mistake. Let's make it 1 and use one color for the palette, that is bright red, and we use this visualization to visualize our burned area classified image. Then convert the mask raster to a vector feature collection. For this we need to use a reduceToVector function, and in this reduceToVector function geometry we pass the region of interest geometry. For coordinate reference system we use the same coordinate reference system of our Sentinel-2 image, and scale is 10 meters. For max pixels, we use 10 to the power 13. This is the highest value so that you can cover maximum area. For reducer, we used ee.reducer.count every. This reducer simply groups connected pixels to the regions. And for the label property, we used burn class. This will add a burn class attribute or column to the shapefile or any other output vector that you export. Next, we defined a style parameter to visualize these burn polygons and add it to the map. Finally, we initiate the export task to Google Drive. To export, we use this Earth Engine export function, that is export.table.toDrive, and then in this function we pass the collection. Collection is our burned polygons vector file. Here is the description of the file, and you can name a folder. In this folder of your Google Drive, the file will be saved, and then file name prefix, we used burned area. This will be the file name, and this description will be the task name. Let's run the whole code at once and see the result. The layers have been loaded. If we turn off this classified image, we can see the burned area. This one is the burned area image, and if we turn off this one is the vector file that we have already sent to export. If you go to this task tab, then you will see a new unsubmitted tasks there. Now let's run this to export shapefile. Here you can change the file format if you want to make it KML or even GeoJSON. And also there are options for cloud storage, Earth Engine asset, feature view asset, BigQuery, and other things. Let's run this. It will take some time. When export process is done, you will see a button called Open in Drive. Let's wait for some moments. We can see it's done under 1 minute. Now we can see this Open in Drive button. Let's click it, and we can see the burned area shapefile, the main shapefile and associated files. Now let's download all these files. Select all and download. File is downloaded to our downloads folder. This is the file we have downloaded. Let's extract it. We have opened our QGIS. Let's add a base map. This one is our downloaded shapefile and extracted burned area shape. Let's bring it to a project. Go to layers and zoom to layer. If we turn off satellite imagery, then we can see the actual shapefile. It will not completely match with Google satellite image because we used Sentinel image. You can see we have lot of smaller polygons. Now we can filter and remove those. Let's turn this off and change the symbology to something like outline and apply. Okay, here we can see some very smaller polygons which we want to remove. For that, we can go to the attribute table. We can calculate the area of each polygon. For that, go to this open field calculator and create new field. Make it area, and then make it decimal number. Precision is 3, and here we need to write $area to calculate the area and apply. Okay, now close. Now we have one area column. Let's go to this select feature using an expression and fields and values. Let's click area is less than 200 meters square, and click select features. You can see we have selected 111 features, and those smaller features are selected. If you want to expand your selection more, then you can also make it like 500 and select feature. Now we have more selections, that is 180. Let's close this, and since this is in edit mode, we can just click delete selected and delete 180 features. Now smaller polygons has been deleted. And also, if you look at closely, you will see the borders are pixelated because this has been generated from Sentinel-2 image. Let's smooth it out. Go to processing toolbox and search for smooth. From this vector geometry, double click smooth and select the vector area. Iterations, we can make 10 iterations. For the offset value, let's make it 1, and maximum node angle to smooth 180. It's completely fine. Let's run and create a temporary layer. Close. Now if we look at the new shape, you see all those pointing shapes has been converted to a smooth polygon. Let's turn off this burned area and make it red color. We can see the burned areas. This way you can easily classify any kind of objects in geospatial dataset using machine learning algorithm like random forest. Thanks for watching.